Okay, here we go, class. Ready for the next math lesson. Today we are working on Module 2, Lesson 9. Module 2, Lesson 9 is called Sequencing Rotations, meaning putting rotations in order, doing one rotation and then doing another rotation. So you'll need pages 93 through 104 of your math workbook for Eureka Math. So get those pages out, get your supplies ready, and start copying these notes into your notebook or on your note page. The road so far what we've studied the three rigid motions: translate, reflect, and rotate. When you translate, you follow the rule made by a vector. When you reflect, you follow the rule of the line of reflection. And when you rotate, you follow the rule of points and degrees. The point is what you spin around, and the degrees tells you how much. And so today we're actually going to focus on rotate. We're going to focus on rotations today. So you need to pay attention to what point we are spinning around, and you need to pay attention to the degrees that tells us how much to spin. Now on some questions today, they're going to want you to rotate however many degrees you'd like. On other questions, they're going to tell us how much to rotate. But we'll get to that when we talk about it. In fact, the whole today's whole thing is pretty much an exploration day. We're exploring the day. It's an exploration activity about rotations. We're going to look at some properties of rotations. It's an exploration activity about rotations to learn some math properties. So as we work today, we're going to go back to our note page and we're going to add the properties that we learned. We're going to add the properties that we learned at the bottom of our note page. So make sure you leave some space open at the bottom of your page. Not a lot of notes today because today we're exploring. We're looking into things. We are figuring things out by doing. We call this learning by doing. So if you're one of the people who like to try things and work with your hands and that's how you learn best, then this lesson is for you. So those are the notes. Hopefully you can hopefully you've copied the notes down with me. Hopefully you've been copying them as I've been talking, because we are ready to move on to the first page of our exploration. The first page of our exploration is page 93, and 93 it says it's an exploratory challenge. So here's our exploratory challenge where you see a triangle ABC right down here, and you see 2 points that we are probably going to have to rotate around. You see point D and you see point E. And we know that points are what we rotate around. So we're going to do some rotation. So let's just keep it easy, do one at a time. Letter A says rotate triangle ABC. So that's what we're rotating, triangle ABC. D degrees. Now they did not tell us how many degrees. They just said a variable D, which means we can pick how many degrees we want to rotate. So we all might pick something different. And then the third thing, so we're going to rotate it however many degrees we want around center D. So we're going to start with point D right here. We're not even going to think about point E yet. Point E will be for later. And then the last thing we're going to do is label the rotated image. So let's do the rotation. For this, I need my transparency. You can see my transparency right there. And I need a dry erase marker. And I am rotating around point D. So let me label point D on my transparency so that I know what I am spinning around. So there it is. You can kind of see it. And then let me trace my triangle ABC so that, because that is what is getting rotated. And I'm going to label the points so that I remember where the points were after the rotation. So everything is labeled. Now I'm ready to rotate. Now it says rotate D degrees, so I can rotate however much I want. They did not give me that instruction. So I'm just going to start spinning, start rotating. D stays in the same place, so the little green dot I made has to stay on D. But I'm going to spin, and I think I'll stop like right there. That looks like a good place for me to stop. So my green mark is still on D, so I know this. I rotated around D. And now I'm ready to sneak my pen under the transparency, and I'm going to mark C. I'm going to mark B, and I'm going to mark A. And then I'm going to get my straight edge, something straight that you can use to connect the dots and put the triangle. So I'm going to connect there. I connect there. And finally, I connect right there. And then I need to label. So this is another reason why I left the labels on the transparency. I put ABC on the transparency because this tells me that this is going to be A prime because that's where A rotated to. This is B prime because that's where B rotated to. And this here is C prime because that's where C rotated to. So that is all we had to do for part A. We just had to rotate ABC around center D, and I labeled that one in blue. So I'm going to circle part A in blue because my blue triangle is for part A. Part A is done. I rotated, I labeled. Let's look at part B. Part B says to rotate triangle A prime, B prime, C prime around center E. So look at so this time I'm rotating the prime triangle. I'm rotating the one I made. This is the one that gets rotated. It still says D degrees, so I can pick however much I want. But this time it says center E. So now I'm going to look over here at center E. I'm done with D. So let's put my transparency back up here. See, I still have the triangle on my transparency, so I'm going to keep it there. But I don't need D anymore. I'm going to use E right here. So now I have a red dot that I lined up with point E, and I'm ready to rotate the prime triangle around E. So, and I can rotate however much I want. I think I'm going to, let's see, I'll slide my page down so you can see it a little bit better. I think I'm going to stop right, let's just stop right here. That way it fits on the page and we can see it. Now I'm going to label my points by sneaking underneath the transparency. I'm going to use my straight edge to connect my points to see the triangle. And then the last thing I have to do is label. And if you look at the instructions told me to label it with A prime prime, B prime prime, C prime prime. So this time I'm going to label it in red. So the red triangle is for part B. So this up here is going to be A prime prime. This is B prime prime. And down here we have C prime prime. So I did two rotations. First, I rotated around D and stopped here. And then I rotated around E and stopped right here. Now, for part C, it's asking me to measure and label the angles and sides of triangle ABC. and then compare them with the images of A prime, B prime, C prime, and A prime prime, B prime prime, C prime prime. So it wants us to measure and label all the sides and angles. So I'm going to get my ruler, and I'm going to measure the sides, and I'm going to see, okay, well, AB looks like it's about 2.1 centimeters. AB looks like it's about 2.1 centimeters. What about A prime, B prime? Also about 2.1 centimeters. What about A prime prime, B prime prime? Also 2.1 centimeters. So all of these sides, all three of these are the same. In fact, I'm just going to stop there to save some time, because what you're going to find out is that all three triangles, if you measure and take the time, have the same angles and same side lengths. The lengths of the sides are all the same, and the angles are all the same. In fact, we have three identical triangles, three, using a vocabulary word here, congruent triangles. And part D is asking us, how can you explain that? How do you know? How can you explain that we have three identical triangles, three congruent triangles? Well, this goes back to the fact that we've been talking about for a few lessons now. A rotation is a rigid motion, which means equals it keeps congruence. Rigid motions keep congruence. They keep the same shape, same size. So rotations do not change shape or size. So we're actually going to add that to our notes on our note page, because that is one of the properties that we can observe when we do a sequence of rotations. So the properties observed, I have on the bottom of my note page underneath the Today notes, I put a section called Properties Observed. And so the first property we see, the first thing we learned from page 93, page 93 taught us that multiple rotations do not change size or shape. Last week we learned that one rotation does not change size or shape. Today we learned that more than one, multiple rotations do not change size or shape. So that is the first property we observed after working on page 93. Take a minute to finish up your notes, finish up your answers on from page 93, and unpause the video when you are ready to continue on to page 94. Okay, now that we've done page 93 and learned one property of multiple rotations, let's go to page 94 and see if we can learn something else about multiple rotations. Top of page 94 doesn't have much on it except for the letter E. Let's slide down so we can actually see the triangle and the work that we'll be working with. Again, you can see that there's a triangle that is probably what we're rotating. And you can see 2 points, D and E, which is what we will be rotating around. So let's look and do one piece of the problem at a time. Let's not get overwhelmed. Let's just look at one step. The first step is letter A. Rotate triangle ABC. So I'm rotating triangle ABC. D degrees, so I get to pick how many degrees I rotate. Around center D, so I'm starting with D. And then, rotate again D degrees around center E. So I'm going to do 2 rotations, and then I will label after both rotations. So let's do the first rotation. Remember, the first one said rotate D degrees around D. So I'm going to get my transparency, put it on top. I'm going to label point D so that I make sure my center stays on center. I'm going to trace the triangle ABC because that is what is getting rotated. And I'm ready to rotate around D. So let's rotate around D, and it says I can rotate as much as I want. So how about I just stop right there? But I'm not done yet. That was the first step. Rotate D degrees around D. Then rotate again D degrees around E. So now I need to rotate around E. So I'm going to label E. And I'm going to rotate, and this time E is going to stay in the same spot. So I don't need D anymore. So let me rotate around E, and I'm going to stop right, let's stop right there. Let me slide down a little bit so you can see where I stopped. Now I get to, now I did the rotation around D, then I did the rotation around E. Now the last thing I do is label. So let me sneak my pen under the transparency, label the vertices of the triangle, and then move my transparency out of the way, get my straight edge, connect my dots so I can see what my image looks like. What image did I make? And if I did this well, if I was precise, and if you were precise, we should have 2 triangles that look the same, just in different places. Let's not forget to label. This is going to be A prime. This point is B prime. And up here is C prime. And that's what they wanted us to do for letter A. We did letter A. We rotated around D, then we rotated around E, and then we labeled. Done with that first section. Next, let's look at part B. Part B is asking a question. Can a single rotation around center D map the prime back? So can we go back? So it's asking, can we go back using just D? Can we go back using just D? So let's try it. Let's see if we can go back using just letter D. So here's my transparency again. I'm going to trace the triangle I made. And I'm going to put a dot on D and see, can I go back if I just use D? So let's try it. Let's try spinning back and only using D. Doesn't look like I can do it. I mean, I just keep getting farther away. The closest I can get is right there. I can get close, but that doesn't move the triangle back. So if I just use D, I cannot get back to where I started from. So I cannot get back to where I started from. Interesting. So part B, can we go back if we just use D? No, we can't. That's the answer. Let's look at letter C. Can a single rotation around center E map the prime onto the original? So this one is asking, can we go back using just E? Can we go back if we just use E? Why don't you make a prediction at this point? Write down your prediction and see, and tell me, do you think you can go back if you just use point E? Make a quick prediction. Pause the video if you have to. But let's test it. Let's erase the D because we don't need that anymore because we're testing to see if we can go back with just E. So let's, on the transparency, let's rotate. Let's keep E where it is and rotate back and see if we can get back to where we started. And that does not look like I'm back. I'm not touching it again. I mean, E is in the same place, but the triangles are far away from each other. That might be the closest I get. That's touching the original, but that's not lined up with the original. And now if I just keep going, I just keep getting farther and farther away. So obviously, if I just use E, I cannot go back either. So can we go back using just E? No, we can't. So hopefully your prediction was correct and you realize that. Now the question is, can you find a center that would go back? So is there a point that will take us back? We know D and E do not take us back, but can we find another point that will? This might be a fun thing to explore with your transparency. Just erase both D and E and see, how do we get back? Like, which point will take us back? And this might be a fun thing to do, to try to spin and see. It looks like there might be a point because I can spin my transparency and get it back. I can spin and get it back. And I'm guessing it might be like about right here. Let's try that. Let's try putting a point right there and seeing if that will work. Let's try seeing if this point will work. I'm just going to guess. Keep that point the same. No, not exactly. So that point didn't work. So let's try it again. Let's try moving it a little bit more over here and seeing how that works. Let's put the point here this time and see if I can get that work. This is going to be like a trial and error thing. See if you can find it. Nope, that one didn't work either. If you want, you can pause the video, you can work on this, you can try to figure out where exactly the point is that will take us back. But the important point of today is not how to find the point that will take you back. That is something you will learn in high school geometry, how to find point F. Because is there a point that will take us back? The answer is yes. But right now in 8th grade, the way you just have to try, it's a trial and error thing. So you try something, and if it doesn't work, you try something else. You will learn how to find point F exactly in high school. So, but right now you just have to know that yes, there is a point somewhere, but that E and D will not work. So let's add another property to our note page. Let's do another property right here. So I'm sorry about that. I messed up my words. So a property that we learned from page 94 is that a sequence of rotations more than one rotation cannot be undone by using one of the points. A sequence of rotations cannot be undone by using just one of the points. You will need a different point. That's why they had us looking for point F. A sequence of rotations will not be undone by one point. You'll need a different point to undo it. So that's what we learned from page 94 right here. How to do two rotations around two different points. And we learned that if we want to go back, we need a third point that takes some work to find. So that's page 94. Catch up, please, on page 94. Write your answers down. Pause if you need to. Add your answers. Add to your notes. And we will get ready to move to page 95 in just 1 minute. Okay, hopefully you finished your notes about page 94. You have your understanding of page 94. Now let's move to page 95 and exploratory activity number 3, which looks like this. The triangle came back. It's the same triangle, and we still have point D, we still have point E, but this is an exploration. So we are working on rotating still. So let's remember, we're just going to follow the instructions one at a time. We're not going to overwhelm ourselves by reading everything. Let's just do step by step. Just like if you're cooking, just like if you're building something, you follow the steps in order. So let's look at part A and see what this page has to teach us. It says rotate. We're rotating again. Triangle ABC. And this time it says 90 degrees. So this time it told us how much. Around center D. And then rotate again another 90 degrees around center E. Okay, so we're going to do 2 rotations. We're going to start with center D, and we're going to go 90 degrees. Now, let me show you how to rotate exactly 90 degrees, especially if you do not have a protractor. Now, if you have a protractor like this and you need to go 90 degrees, this is what you do. You put the line in the bottom middle of your protractor at D. So see how this line at the bottom is lined up with D. And you put a line going to 0. That's 0. And you put a line at 90 degrees straight up. And then you connect the point and the line going straight up. That is a 90-degree angle. You can even put the symbol for 90 degrees on a box like that. Now, some of you are saying, Mr. Braille, what if I don't have a protractor? Well, you can come to me and you can ask for a protractor because I have a box of them at school. Or here's a trick. If you don't have a protractor, all you need is something that is a square or a rectangle, something with a 90-degree angle. So you can use a ruler. And let me show you with dot E how to do 90 degrees. You need a square like a ruler, or you can use a bookmark. Anything. You can even use like a little Post-it note where you just do the corner of the Post-it note. All you need is something with a 90-degree edge, something with a corner. So I'm just going to use the ruler, and I'm just going to put it just like that with E going right here on the corner. So if you need to go 90 degrees, all you do is you hold that there, and you trace both sides just like that. And if you look, that is also 90 degrees. So you don't need a protractor. A protractor might help, but to do 90 degrees is super easy because you just need a rectangle or something square, something that will make a 90-degree angle. So because we're going 90 degrees, I labeled both of these at 90 degrees and 90 degrees. And that will help me with my rotations, because here's 0 degrees. Let me label 0 degrees also. 0 degrees, 90, 0 degrees, 90. Now I am ready to start my rotations because I have my degrees labeled. So to do my rotations, I will need my transparency. Now going back to letter A, the first instruction was rotate 90 degrees around D. So let me trace my triangle. And here's how we rotate degrees. I'm going to put a dot. I'm going to round letter D, so I'm going to put a dot on D, and then I'm going to put an arrow pointing to the 0 degrees. Very important, you label D and you have your arrow, because the arrow is going to tell you when you hit 90 degrees. Watch. Because when I start at D and I start spinning, I need to stop at exactly 90 degrees. So I stop when my arrow points to 90 degrees. So if you followed all the steps I asked you to do, the triangle goes, let me slide my paper down so you can see, triangle goes right there at 90 degrees. My arrow is pointing to 90 degrees, so I rotated 90 degrees. That is why I was so precise with setting up my rotation. I paid attention to what I was doing. I set it up super well, and so I know exactly when I hit 90 degrees. So if you want to do this precisely, and you should want to do this precisely, you need to do exactly what I just did. Now, that was the first step. Rotate around D. Then I need to rotate another 90 degrees around E. So I need to keep my triangle where it is. And this time, I'm going to rotate around E. So I need another arrow that starts at E, pointing at 0, so that I can rotate again. So here we go. I rotated around D. Now I'm rotating around E. So here we go. And I'm going to stop exactly when the arrow is pointing at 90 degrees. Now I'm ready to label. I accidentally labeled a little bit early. Should not have done that, but I'm ready to label now after both my rotations. I rotated around D, I rotated around E, and I used my labels and my arrow to go exactly 90 degrees. I'm putting my points, I'm sneaking my pen underneath the transparency. Now I'm going to erase the points that I accidentally put on there. We don't need those. I'm going to get my straight edge to label the new triangle after both rotations. And there is the triangle after both rotations. I'm going to label it with prime. So this is B prime, A prime, and C prime. So your triangle should look exactly like mine and be in the exact same place, because everybody was supposed to go 90 degrees. So there we go. That is part A. Part A is done, and I did it in blue, so I'm going to label my part A in blue. Part B now. Rotate triangle ABC 90 degrees around center E and then rotate the image another 90 degrees around center D and label it the prime prime. Now you'll notice this sounds a lot like letter A, except there's a difference. In letter A, we did center D first. In letter B, we're doing E first, then D. Do you see how they switched what order we use the points? So the order of the points switched. So let's try this. So I still notice I still have my labels for 90 degrees. That's going to be super helpful. I'm going to use them again. So my transparency goes back. And I'm going to label my triangle again because I'm going to rotate it again. This time I'm labeling it in red. So it's different from the first one that was blue. And the instructions were for letter B to use center E first. So I'm going to use center E first. And there's my arrow with center E. And I'm going to rotate until my arrow points at 90 because it told me 90 degrees. So here we go. Rotate all the way, and when your arrow points to 90, that's the rotation is done. So I did the first step right there. The arrow points to 90, so that's where I stop. Next step, that was around E. It also wants me to rotate around D 90 degrees. So I'm going to use my arrow and put it with D at 0. And now I'm going to rotate until D is at 90. So let's rotate going D to 90. And we are off my page. You can see I am off my page. So whoever planned this did not plan it super well. So I do not have enough room to do this, but I can still do a little bit of the triangle on my paper. I don't know if the triangle is off your page, but it is definitely off my page. But even if it's off the page, we can still talk about what we learned. We can still learn something. You can see that the triangles, when I used D first, it stopped right here. When I used E first, I stopped way up over here. Two very different places. So part C, what do we notice about the locations? First, we notice they are in different locations. And so does the order you rotate a figure around different centers have an impact? Yes. The order of rotation around different centers matters. The order of rotations around different centers matters. It matters if you did D or E first. It matters. And that is the property we observed. That is the property we're going to add to our notes. So I'm going to go back to my note page. And I'm going to, right here in the blank I left right here, page 95 taught us the order of rotation around different centers matters. When the centers are different, the order matters. When the centers are different, the order matters. And that is the big lesson from our exploration on page 95. So take a minute to update your notes. Take a minute to look at page 95, finish page 95, and observe how the order of rotations matters. When you're ready, unpause the video and we'll move on to talk about the next page of the lesson. Okay, hopefully you finished page 95. You understand everything about page 95 and you've updated your notes. Let's move on to the final property we're going to look at, kind of connected to this one, on page 96. So everyone looking at page 96, you'll see the triangle is back. We have a triangle here, triangle ABC. I'm getting very used to that triangle. You'll notice a difference on this page, though. There's only 1 point. There's only D. E is not here anymore. So to this property, this page, we're going to look at what properties we get when there's only 1 point. So let's read part A, see what we have to do first. Rotate triangle ABC. We're going to rotate triangle ABC. And then this says 90 degrees around center D. So that's step 1. Rotate 90 degrees around D. And then rotate again, 45 degrees this time, excuse me, also around center D. So first we're going to rotate 90, and then we're going to rotate 45. So to help us with our rotations, it might be useful if we label the degrees around D so that we can know exactly, precisely where we're going to rotate. So again, you can use a protractor. And since we're doing 90 degrees first, let me label 90 degrees. So I have a line for 0. That's 0 degrees, following the bottom of the protractor. And I'm going to make a little line at the 90-degree line. Here's the 90-degree line, so there's my line. And then I'm going to connect right here. And I'm going to label 0 degrees and 90 degrees. So that will help me rotate 90 degrees. Now, it also says, I'm going to plan ahead a little bit right here, where it says, after I do 90, I need to do 45 degrees. So after the, so I might want to label a little bit more than just the 90. I might want to label 45s. So I'm actually going to label 45 degrees. So here's 0. I count up by 10s, 10, 20, 30, 40. Count up by 5s. And this right here is 45 degrees. I'm also going to go 45 degrees after the 90 to do 45 degrees on this side, which works out to be over here. This is 135 degrees. So I have 0 degrees, 45 degrees, 90 degrees, 135 degrees. I labeled all of my degrees to help me make sure I have precise rotations. Remember, it's all about being exact. It's all about being precise. Now, you might be saying, Mr. Baylor, what if I don't have a protractor? How do I do this? It's a little bit more complicated, but you can still do it. The way you do it is, I showed you on the last page how to do 0 and 90. What you kind of do is you cut it in half. You try to cut it exactly in half, because 45 degrees is half of 90. So what you can do is you can do, after you have 90, you go like an inch here. And you go an inch toward 0. You go an inch toward 90. And you make a little bit of a box. Make a little bit of a box. So after you make, if you make a little square, right here, 45 degrees, so if you make a square in between 0 and 90, 45 degrees is the diagonal that connects the square corners. So that's how you can do it if you don't have a protractor. But again, if you want a protractor, it might make your life easier. I think they cost like 25 cents at the store. If you want a nice one, it might be $1, or you can come get one from me. But now that we have our degrees labeled, let's start our rotations. So we're going to need our transparency. So let's label our triangle that we are rotating, ABC. And it says for part A, first thing we have to do, 90 degrees around D. So I'm going to put 90 degrees around center D. So let's rotate, and I'm going to keep D lined up in the center, and I'm going to stop when my arrow is pointing at 90. So that's where it goes right there. Then the next step said rotate 45 degrees around D. Rotate a 40. So I'm going to put another arrow, and this time I'm going to stop when it gets to 45 degrees, which is right there. So I did 90 and then I did 45. Let me draw where my triangle goes. Let me sneak my points in under the transparency. And then let me get my straight edge to connect my points and finish the triangle's image. And there we have it. And I'm going to label it like it told me to with the prime. This is C prime. This is A prime, and this is B prime. So it's labeled. So I did 90 degrees, then I did 45 degrees, and I stopped here. For part B, this time it's almost exactly like part A, except for this time I'm going to do 45 degrees first and 90 degrees second. So the first one I'm going to do 90. The first one I'm going to do 45 and then 90. I'm still using the same triangle. I'm still using center D. I'm just switching up the order of the degrees. So let me put this back. Let me erase this arrow. And let me go 45 degrees first. So I'm going to stop when my arrow is pointing on the 45-degree line. So that's the first step. Now I need to go 90 degrees. So I'm going to do another arrow pointing to 0. And I can erase my first arrow because that one did its job. And I'm going to go this time, I'm going to go 90 degrees. So the arrow needs to be pointing straight up at the 90. And look at that. The triangle is in exactly the same place as part A. So all I have to do right now is I already drew it. I mean, I can trace it with red to make the line look purplish. But the triangles from part A and part B are in exactly the same location. So A prime prime, B prime prime, C prime prime are in the same place as A prime, B prime, and C prime. So that answers question C, part C. What do you notice about the locations? You can just write same exact location. And then does the order in which you rotate a figure around the same center matter? Does it matter if you rotate around the same center? And you can see, because both triangles stopped in the same place, when we only have one center, the order does not matter. The order does not matter when there's only one center. So let's add that to our observed properties on our notes. And let's say, the fourth property we observed today on page 96, the order of rotation around one center does not matter. The order of rotation around one center does not matter. On page 95, the order around different centers matters. Page 96, one center, the order does not matter. So that's another property we learned about sequences of rotations. Copy that in your notes, please, on your properties list. Make sure you have page 96 completed, that you understand page 96, and that you can see how to rotate, and you know that the order with only one center does not matter. Pause the video if you need to, look at it, your notes again, and look at your page again, and then unpause when you are ready to move on to page 97. Okay, so we finished page 96. Your notes are updated, and you realize that both triangles are in the same location. So the order around the same center does not matter. Let's go to page 97. 97 is asking us to visualize and explain how to return things, how to return figures, how to reverse transformations. So if you look at number 5 on page 97, it says triangle ABC. This one right here, triangle ABC, the original, has been rotated around 2 different centers. It's been rotated around 2 different centers. And its image is triangle A prime, B prime, C prime. So it's been rotated around 2 different centers. And now it wants a sequence of rigid motions that would move it back. A sequence of rigid motions that would move it back. So in other words, how do we make them line up? How do we make them line up? Again, how do we get them to match perfectly in the same exact spot? How do we get them in the same exact spot? How do we transform them to be in the same exact spot? Now you might say rotations, except the problem with the rotations is that, remember, we need to be precise, and we don't know where the centers are. And we don't know how many degrees. So rotations would be tough. To just use rotations would be tough. What we can do, I would like to start with a translation, a slide. So what I would say is let's follow the vector. Let's make a vector. So I'm going to make a vector with my green pen. So I made this vector, so everyone sees that vector. So step 1, I would translate on vector C prime. I would translate on that vector, C prime. So let me show you what I'm talking about here with my transparency. So I want to start with the original right here, and I want to move it back. So step 1 is to follow this vector right there. Do you see how step 1 is translate on the vector? I slide it right there. Now it's right here. I still need to figure out how to move it back. Now you might be saying, okay, well, you probably figured it out already. How do we move it back? Well, to move it to the rest of the way, C is in the right spot, but A and B are over here. They need to be up here. So to keep C in the right spot, we rotate around C. And then that's how we get to the right spot. So step 1 was to translate on vector C, C prime. Step 2, rotate around point C prime, because that's what we're spinning around. So the first step is we slide on the green vector, vector C, C prime, and then we rotate around C prime until they line up exactly. So you can see that is how, this is the explanation for how we move them back. We slide and then we spin. So that is the best way to do it, because that gives us the, and if you notice, my explanation did not just say translate and rotate. I told you the rules also. I told you the vector you use, and I told you what point we rotate around. You cannot just say translate and rotate. You have to tell me the rules also. You have to tell me what you do and what rule you follow. What you do and what rule you follow. That's a good explanation. And you are going to have an opportunity to practice this in your work today. Let's move on to what work you need to do today. This is the lesson summary, talking about what we did. You should have all of these facts in your notes already, so we'll move on from this page. The exit ticket on page 99, I want you to slide to the back because that's going to be your final assessment today. On page 100 and 102 is the homework helper, where they do another example with you. So if you still are having a little bit of difficulty and you want to look at another example, look at the homework helper on 101 and 102. They show you what happens, and they even have explanations about what they did. Your problem set on page 103 and 104 is what you're going to do to practice today, and I will have my answers posted online so that you can check your work. And a lot of it is what we already did in class today. For number 1, you're going to rotate the angle ABC. So it's not a triangle, it's an ABC. It's an angle and it's a segment. So you're going to rotate these things however they tell you to. Looks like you have 2 centers, F and G. So pay attention to what center you rotate around first. Pay attention to what center goes first. And then they're going to ask you to see how, if the angles and the segment change at all. Now you probably already know the angle and segment are not going to change because these are rigid motions, but that's just what they're asking you to prove again. For number 2 on the problem set, they're having you rotate a triangle 90 degrees, so you have to practice your 90-degree rotations around center O, and then a negative 45-degree rotation around center Q. So you're going to label, and you're going to label that image, and then you're going to talk about how to move the triangle back. Part B is how you describe how you move it back. So 2 rotations, and then how do you move the triangle back? For number 3 on page 104, you have a triangle and a center, and you're going to rotate it negative 90 degrees around center O, and then you're going to rotate it negative 45 degrees around center O. And then you're going to label both the images. And you're going to see what differences that makes. Remember, try your best on the problem set. You check your answers with the ones that I post on the Google Classroom, and you should be fine. When you understand all of it and you've checked your answers, you might be ready for the exit ticket, which is on page 99. Remember, you're going to take a picture of the exit ticket. You're going to show me what you learned today. And number 1, let me explain number 1 because not a whole lot of pictures for number 1. It says, let rotation 1, let your first rotation be D degrees around center 0, and let rotation 2 B, the rotation of the same figure, d degrees, around center P. So, and it's saying, so you have two centers, one figure rotating around two centers. Does the rotation of the figure, it's asking, does the order matter if you go around center O first or center P first? Does the order matter is what it's asking when there are two centers. Use your notes, use your examples, explain why the order does matter or explain why the order does not matter. Number 2, angle ABC went through a whole bunch of rotations. The original size was 37 degrees. What is the size after the rotations? So it's asking, does the angle change after rotations? And don't forget to explain why or why not the angle changes. And then number 3, triangle ABC went through rotations around two different centers to make ABC prime. I want you to tell me how to move it back. How do you move it back? How do you move triangle A prime, B prime, C prime back to triangle ABC? And you'll probably need at least 2 steps. And remember to write what you do and the rule you follow when you do it. So that will be your exit ticket. That will be what you take a picture of and turn in on the Google Classroom. Thank you for paying attention today. Thank you for being here for the whole lesson. If you need anything, please remember to reach out to me in an email or leave a question on our Padlet. But I will see you for the next lesson.